All right, so chapter 5, folks, is all about algebra. Now, we are not going to get into super deep algebra analysis in this class, okay? It's a 1-week introduction to basic one-variable algebra, okay? And the goal behind me teaching you algebra, folks, is really so that you can solve the basic problems that are required of you in the real world today, okay? Not super scary, bizarre, like 3-variable equations and all that other kind of crap. None of that. That's not the goal behind this, okay? So, but the idea is that what I'm really trying to do is to show you that algebra can be a tool, okay? You can use it to solve certain problems. And sort of the trick is figuring out when does it help, all right? And that's part of what I'm trying to do, is to show you when is it going to be to your advantage to try and write out a little bit of algebra. It doesn't have to be, a big, huge, long equation with tons of crap floating around in it. Usually it's relatively short and sweet, and it just gives you the simplification you need to know what you need to do to solve things, okay? So, anyways, with any new chapter, I tend to start with the terminology first, okay? So, terminology in algebra, these are just words that you're going to hear me say that you're going to have to make sure you can deal with, all right? Some of them I would like to think doesn't require a whole lot of explanation, but just to be safe. Okay, folks, what's a constant?
Something that doesn't change.
Yeah, something that doesn't change, or it's a number. So when I say the phrase, what's the constant? What I'm asking you for is a number by itself. Okay? And you guys know that numbers can sometimes come with variables. Those have different terms. They have different terminology for it, right? So constants, the 2, sort of your classic constant, okay? And you can have other examples, right? So you can have 0. Don't forget 0 is one of my favorite numbers. You can have fractions, and they can be negative, right? Whatever. Okay. Please note that there are some constants that are actually written with no numbers in them. You guys think of a constant, a number that we write without writing any numbers?
Pi.
That's the classic one, right?
What about I?
I is an imaginary number, so it doesn't quite fit into the realm of constant because it's imaginary. But it is the same concept, yes. E would have been the other number that you could look for that tends to be a number we write without actually writing a number, right? So you guys know what pi generally means. Even though it's a letter, you know that what it really is a number, okay? So, a variable. Please note that the book, for whatever reason, it seems to think that variable is a scary word, so it tries not to use that word. It actually, for whatever reason, tends to use the phrase unknown instead. Anything that's an unknown is a variable. And they actually don't even say the phrase variable very often. But you're old enough and smart enough you can handle the word variable, so just realize I'm going to say it, okay? So if I say, what's the variable, you should know what I mean, okay? Unknown value represented, there's an ED in that, I swear. It's represented by a letter, and I put letter in quotes because it doesn't have to be a letter, folks. You can use more than one letter to describe a variable or an unknown if you wish. But what's the classic example of a variable?
X.
Yeah, and it's what I am going to use all the time in this class. Okay, folks? I'm an old school math guy. I've been using X for as long as I can remember. Just bear with me, okay? All right. You can use other letters if you like. You're more than welcome to use Y. Note my Z always has a slash through it to differentiate between the two. Sometimes my 2's will look exactly like a Z, but there won't be the slash between it. If you like to use capital letters, it's okay, right? If you like to switch into foreign languages, that's fine too. Right? I had a student one semester who took my advice because I tell students, math is kind of boring. If you just write X's all the time, it's kind of dry and dull. And so what I told them is that you can use wingdings. For those of you that are old enough that know what those used to be, those are emojis, or what made emojis happen, right? You can use pictures, right? So if you want to use a little smiley face for your variables, that's fine. Or if if you're not liking math too much, right? You can make it a friendly face. I did have a student one semester who used a heart for every variable. And when they were sad, guess what they did to the heart? They broke it. It was really weird, but it was also really fun. I had fun grading that piece of homework every week because I knew it was going to become a heart. And there was one week where she had arrows going through it because it was down. And she was really bad off. She would actually color them all red. It was really weird. Okay, so it's okay if you do that, but I am going to look at you funny, just so you know. And as long as you're okay with that, it's all good. All right? The other thing that I like to tell students is that you don't necessarily have to use one letter when describing a variable. You can use a name. Okay? So instead of using X, you can say, if the question is talking about, well, how much money does Joe have, right? Instead of writing Joe as X, which doesn't really give it a whole lot of meaning, just use the whole name Joe. I'll understand that you mean X, and that if you have 2 Joes and you add 3 Joes and you say that you have 5 Joes, I'm like, well, that makes sense, right? Because if you take 2 Joes in a group and put 3 more Joes together, you've got 5 Joes together. They work just like X's, okay? That's the cool thing about it, right? Variables and unknowns, that's us. Every one of you, to me, right now, is still an unknown, right? I can't remember any of your names because you weren't here for 2 weeks. So you are all going to have to continually remind me who you are so that I can remember who you are, because it's been 2 weeks since I've seen any of you. So bear with me to some degree as I try and figure out who you are. So, again, this is just me saying, hey, realize that that's part of the game, right? Don't necessarily go down the sort of, you learned math back in 5th grade and somebody said, you always have to use X's, and they were banging you on the side of the head while you did it, There's a little bit more freedom now, so let it go, all right? All right, so the other thing that I will sometimes talk about in this class, and you just have to bear with me when I say it because it's a very mathy way of saying things, but I will talk about it, right? I will say, what's your expression, okay? And an expression, all that is a combination of constants and variables with math operators in between. Now, what's a math operator?
Plus, minus.
Okay,
Divide.
good.
Those
Plus, minus, times, division, parentheses are in there. You can think of them as exponents, right? I mean, all the sort of standard stuff that we do in math, right, are math operators that will be in between constants and or variables. Now, you guys remember what that symbol is?
square root.
All right, so what math operator or math symbol are we missing up there? Equals. Note, in an expression, folks, there are no equals. Okay? When you get an equal sign, we call it something else. Then it's an equation. Okay? And the reason why I had to explain what an expression is because I actually use that to define what an equation is. An equation is when you set two expressions equal to each other. Okay? That's the idea. And this is why I want you to understand the phrase expression, because when I talk about one side of an equal sign, I'm going to say, well, what's your expression? What was your first expression in your equation, right? And you should know that that means just tell me what's on the left-hand side of the equal sign, okay? That's all it means, all right? But, again, I'm not going to quiz you over terms, folks. This is more to make sure that when you hear me talking, you know what I'm saying and what I'm talking about, okay? All right, so, please note that some equations are really simple. There's no solving this equation. It's just looking at it and telling me that it's either true or false, right? I mean, you can look at this one and say, hey, Marshall, that's a true equation, okay? Note that is a false equation. It is still an equation, it's just wrong, all right? Realize that equation just implies truth or falsehood onto it. That's it, really, all right? When there's no variables. When there are variables, these are the sorts of equations that you solve. Okay? Once you start getting variables in the equation, then they become solvable equations. Otherwise, if there's no variables floating around, it's really just a truth table. It's a true-false question. Is it true or is it false? And you can either tell me that it is or it isn't. And it's no big deal. Okay? All right. So, not too bad?
I'm sorry, I'm listening. So the second part, the 3 plus 4 equals 12 is false.
Yeah, this is it. This is just, yep. That's an equation that happens to be false, whereas the first one is an equation that happened to be true. All right? And the third equation that we wrote down here is just a solvable equation because it's a variable in there. Once you start throwing in variables, then you guys have to do some work to find the variable or the value of the variable that makes that a true statement. All right? All right, so terminology, not bad? Okay. So one of the things that I will be telling you to do frequently as we are doing algebraic expressions and equations is to simplify things, okay? This is different than solve, folks, all right? And note, it's because we are simplifying expressions, we're not solving equations, right? When you deal with expressions, you don't solve, you simplify, all right? So the idea is that if I gave you this expression, you guys could simplify that expression. How would you do it?
Combine like terms.
Combine like terms, right? So this is the standard phrase that represents simplifying expression. Combine like terms. And so what terms are like in this expression?
The numbers.
Yeah, the 2 and the 5, okay? Please, and this is where you guys have to be careful when you are looking at algebra, is that a lot of times when people see 2 plus 3, what does their brain do immediately?
5.
It's hard sometimes to stop yourself, right? I mean, you see 2 plus 3 and you're like, well, I know it's 5. But you also know that these are not like terms, right? Because this 2 is a constant, this 3 is a part of the x. Therefore, it's different. Therefore, the 2 and the 3 do not get combined together, okay? That expression is the simplified version of the one above it, okay? Simplified. And so one of the things I'm going to be asking you to do while we're doing algebra is often, before you start trying to solve, simplify first. just makes life easier. And it should make sense, right? If someone tells you to simplify the problem, you're like, well, that will make it easier, right? And I'm like, yes. So that's what we'll do. All right? So, if I said that I have 2x minus 4 plus 3x, how would you simplify that expression?
2x and 3x to get the 5x minus 4.
Exactly. You have 2 x's, you get 3 more x's, you now have 5 x's, in which case you really need to learn to make better life decisions. And then subtract 4 because the 4 keeps coming around. Okay? Alright. So either combine numbers or combine x's. Again, we will not do this in this class, but you should be aware of it just to be safe. Note, you can have exponents on your letters.
Do you want it solve?
Simplified, please.
Simplify, well, yeah. You do 2x to the exponent of 2 minus 2x plus 4.
Careful.
Or plus 2x minus 4. Plus 4, sorry.
I know what you meant to say. Alright, so note, since the x here has an exponent of 2 on it, it is not like the x where it doesn't have an exponent. In other words, don't combine x's unless their powers are exactly the same. Now note, in this class, folks, we will not have anything that is squared, okay? So you do not need to worry about it in this class, but it is something I want to show just to be safe.
Are we, in this class, are we going to do where we have to like break down the, like into the...
No, we will not do any factoring.
Oh.
We will not do any of that kind of stuff. All
I
that
just
stuff.
wanted to ask.
Yeah, none of that stuff, okay? The algebra is going to be relatively straightforward and linear, which means no x-rays, okay? Alright. Not bad? Now, you do have to be a little bit careful, right? And this is why we did a lot of that stuff kind of earlier, right? Where if I said, what if I had 4 plus 3x minus 7?
It'd be the 4
3x minus
7.
So the 4 and the 7 need to combine, but note this is a positive 4, this is a minus 7, right?
Yeah.
Right. Think of minus 7 as being you owe somebody $7. The 4 as being you have $4. If you have $4 and you owe somebody $7,
Negative 3.
you're $3 in the hole. Right? So just be careful of signs, okay? And so what that means then is that you have to also be careful of stuff like this.
2x minus 8.
So a minus sign in front of the 3 means you owe somebody $3. The minus sign in front of the 5 means you owe somebody else $5. You owe somebody 3 and you owe somebody 5.
2x minus.
Yeah, you're $8 in the hole, or 2x minus 8. So you just have to be careful with minus signs, okay? And the minus signs can wind up on x's as well, right? So if I gave you 2x plus 2 minus 3x, if you have 2 x's and you took out 3 of them,
Negative 1x.
yeah, you have a negative x in the hole, so you're just waiting to take out the next one you get.
Sounds like my bank account.
So 2x's minus 3x, it is okay to write negative x plus 2. If you wanted to write that as 2 minus x, that's actually okay. All right? I will tend to write the variables first and the constant second, but that's the way I was brought up. Okay? You don't have to do that if you don't want to. All right? All right, so I will often tell you, simplify. And it's your job to simplify. Now, I can also be a bit of a jerk when I ask you to simplify, because I can make you do things like this. What am I making you do in this problem, folks?
Add fractions.
Add and subtract fractions. And this is why I make you do that, because those can show up inside of equations just like they did back in regular problems in chapter 2. So you need to be able to handle it. Now, I didn't make it too bad because I already gave you a common denominator, but the two values that you're combining are the two that are constants, right? Keep the 3x along for the ride. How would you do this subtraction, folks? You could either borrow or convert everything into improper fractions. Please don't forget how to convert things to improper fractions. What is this as an improper fraction? Yeah. 2 times 3 is 6 plus 1 gives you 7. What is 1 2/3? 1 times 3 is 3 plus the 2 gives you 5. Now you can do it since it's a common denominator. What's 7/5 minus, or 7/3 minus 5/3? There you go. And in theory, you could deal with that in an equation. Please note that you won't get fractions in equations very often in this class, okay? But it theoretically could happen. All right? Not too bad? All right. So, the goal of this section is really getting to the ultimate step of solving equations. So, how do we go about solving equations? Well, the key, the goal, and this is a very mathy way of describing it, by the way, folks, to isolate the variable. The idea is to just get the variable by itself on either side of the equal sign. Okay, note, folks, that it doesn't matter where the variable is by itself, on the left-hand side or the right-hand side, perfectly fine. Okay? That's our goal. All right? So, let's do it. The mechanics behind solving equations, folks. Right now, the x is not alone. It's got a plus 3 with it. Folks, how do we get rid of a plus 3? Subtract 3. Equations are all about balance, folks. So if you do something to one side of the equation, you must do it to the other side of the equation as well. And note how I write it, okay? I'm just basically saying minus 3 equals minus 3, which is obviously true, right? And so the idea then is that you add or subtract going up and down, all right? So what is x plus 3 minus 3? X, right? Because the plus 3 and the minus 3 cancel. That's the whole idea. Now x is alone, and then what's 7 minus 3? Okay, and again, I would like to think that you guys probably could have done that beforehand, but this is just me making sure we're all on the same page, and that you notice how I'm going to solve these, okay? So that you are comfortable with it when it comes your time, all right? One of the things I would like you guys to do is to always make a quick check to make sure your answer makes sense, right? So put the x equals 4 back up in here and make sure that the equation you get is true, right? What is 4 plus 3? 7. So when you plug x equals 4 in for x, you had better get an equation that's true. If it is, then this is the solution. If it's not, then you made some kind of a mistake, okay? And we'll talk about that in a little bit, all right? So, and note, folks, that this is one of the 4 major building blocks of solving equations. Okay, that's the first one. Here's the second one. In the first one we added. What am I doing in the second one? Subtracting. How do you get rid of a minus 2, folks? You add 2, and if you do it to one side of the equation, you do it to the other side of the equation. Same idea, right? Except that instead of canceling an addition with subtraction, we're canceling a subtraction with addition. That is the second standard step or tool in your toolbox for solving equations, right? Getting rid of pluses and getting rid of minuses, all right? So if we can get rid of plus or minus, guess what I get to do next?
Multiply it by.
There you go. Those are the other two tools in your toolbox. Note, folks, when you write a number and then a variable right after it, this is implied multiplication, okay? This is saying that there are two x's, which means it is 2 times x. I don't write a little times symbol in here. I don't put a little dot or anything like that inside of there. You just have to know that when a number comes before a variable, it means multiply, okay? And this term, just so that you know, this number is often called the coefficient of the variable. Okay, so whatever is multiplying the variable is often called the coefficient. I will generally try not to use that term, but it may slip out at some point in time, and hopefully you'll know what I mean. Okay? Now, this is multiplication. What's the opposite of multiplication? So how do we get rid of the two? Get rid of this 2 so it's x by itself.
Divided by 2.
We divide by 2. And if you divide by 2 on one side, you divide by 2 on the other side. Again, keep everything balanced. It's the same concept, except now it's multiplication division instead of addition subtraction, which is nice. And what's 14 divided in half? 7. And that's your third tool in your toolbox for solving equations. And then last but not least, here we are taking x and dividing by 3. How do we undo division? Multiplication. And just like everything beforehand, if you do it to one side of the equation, you have to do it to the other. Again, if you take a third of x and triple it, you get yourself up to a full x. And 5 times 3 gives you 15. And those are the 4 standard tools that you will use to solve basically everything in your toolbox, folks. All right? This, you just use variations on the theme for every equation we have in this class. All right? There will be nothing more advanced than using these 4 pieces. And so all of the stuff that you learned in a second semester or a second year of algebra is outside the scope of this class. We're not going to try and go there. All right? All right. So the fun part is when you start putting them together. All right, so one of the things that I like to show before I start jumping into solving things is why I ask you to simplify. Okay? So this problem I put to a test once, and what I had someone do for me once is they said, oh, hey, look, here's a +2. Right? How do I handle a +2, folks?
Subtract it.
You subtract 2. They said, oh, great. So I'm going to show you this. Please do not write it down in your notes because it's wrong. Okay? They said -2, and guess where they put the -2? Instead of putting it on the other side of the equal sign,
Same side.
and then all of a sudden I got 3x plus 2 equals 5. No. Right? You guys see right away that that's wrong, right? Because what's 2 plus 4?
6.
This should be 3x plus 6 equals 5, not 3x plus 2 equals 5. Okay? So one of the things that I'm going to try and drill into you guys is simplify before you start solving. Before you start trying to manipulate each side of an equation, make sure that you combine everything on each side of the equation. Okay? So just be careful with that sort of thing. Okay? Okay. Alright, so this is just me warning you, alright? So let's just do a straightforward one first off, right? 2x plus 3 equals 11. Alright. So here's where we've got addition and multiplication put together. We need to get the x by itself. The idea here, folks, that when you are solving for equations, it is to your advantage 95 to 99% of the time to deal with pluses and minuses first, multiplication and division after. Okay?
Kind of like the order of operations.
Yeah, it's the exact opposite of the order of operations technically, right? Because normally you do multiplication and division first and then addition, but when you're solving, you actually go the opposite direction. Okay? So in other words, what we want to get rid of is this plus 3. So how do I get rid of a plus 3? Subtract the 3. And if you subtract 3 from one side, you got to subtract 3 from the other. 2x, 3 minus 3 cancels, 11 minus 3 gives you the 8. You're not quite there because x is not totally alone.
Divide by 2.
Divide by 2. Note, another way that I write division by 2, folks, please note, I just write it as a division bar, as a fraction bar instead of the division sign. I almost always do that because it's easier than writing a little thing with the dots over it because that's a pain in the ass, right? So I will generally just write the fraction bar, and then it's really easy to see that the 2's cancel this time.
If you just write in 2, do you mark that? Okay.
As long as you get me a correct result at the end, I'm actually okay. All right. Now, once you start getting into equations like this, folks, it's to your advantage to make a quick check at the end, just to be sure, okay? You don't have to do a whole lot of work to do it, but throw the 4 into the x up there and make sure that it works, right? Just in case, right? So if you look up here and you say, oh yeah, 2 times 4, yeah, that's 8. 8 plus 3, yeah, that's 11. That works, okay? And normally the numbers are not too messy, so that won't be too hard to do in your head. But there are times where the numbers are going to be messy, folks. And honestly, my advice, write it out. Just write it out. Write it all the way out. In fact, even if doing that in your head is more than you want to have to do, you can write this out. You can say, oh, this is 2 times 4 plus 3 equals 11. This needs to be true. What's 2 times 4? 8 plus 3 equals 11. What's 8 plus 3? 11 equals 11. This is your true statement. That's your checking mechanism to make sure that your solutions are correct. Okay? So when you're doing your algebra, and there's a few set of problems on the homework that looks like some of you may have already started, this is not necessarily a bad idea just to make sure you got the right answer. Okay? I won't force you to do that. Just like I won't force you to get an A, I will let you get whatever grade you get. Okay? So decide for yourselves whether or not you want to check. Alright. Not too bad though? Alright, so let's see. So what do I need to do first here? Add 1. Both sides. X equals 9. Divide by 3 on both sides. X is 3. Does it make sense? 3 times 3 is 9. 9, this one gets me to the 8. I feel fairly confident. Okay? Now, please be careful when working with these. What am I going to do to solve this thing? What do I do first?
Subtract 2.
All right, good. Note, this 2, folks, it's positive. I don't write the little plus in front of it, right? So the way that I need to get rid of that, since it's a positive 2, is subtracting the 2. And note where I wrote the subtracting 2's. I always write them underneath the numbers that they belong to, so that I make sure I subtract the correct things. You don't have to do this sort of thing. It's just the sort of thing that I will always do just to be safe for myself. Because I am the kind of person, when I get in a hurry, and I write the minus 2 right here, even though this is 4x and it says minus 2 down here, since I'm going fast, I'm going to say, sweet, 4x minus 2 is 2x. Don't let yourself do that. Okay? It can sometimes happen. Alright? And then once you get 4x equals 12,
Do we have to write divided by 4? Can we just...
you don't have to show all the work if you don't want to. If you can do that in your head and tell me that x is 3, that's fine. As long as you get down to x equals 3 at the end, I'm okay. Alright, so, not too bad? Alright, so, let's see. No, what I do here, first of all.
Did it back and throw on.
Yeah, when I put the x on the other side, please note that it doesn't matter. Okay? If x is alone on the left side or x is alone on the right side, it doesn't matter. Now, what else did I throw at you?
Double digits.
Yeah. Uh-huh. What are you going to do first with the right-hand side of this equation?
55.
Yeah. Bring the 15 and the 3 together because they are both combinable terms. They are like terms. Now what do I do? Subtract 12. Again, be careful, right? The 2 is over here with the x. That's what we want to get by itself. Now you got to be a little bit careful with this, right? What's 5 minus 12?
Negative 7 equals 2x.
Negative 7 equals 2x. Be careful with the minus signs, right? If you owe somebody $12 and you got $5 in your pocket, there's still $7 in the hole, right? Now what do I do?
Divide by x equals negative 3 and a half.
Yeah, cut things in half. What's half of 7?
3 and a half.
And you can write 3.5 however you want, folks, right? You can write it as negative 3.5. If you want to write it as negative 3.5, I am okay with that. If you want to write it as negative 7/2, I'm actually okay with that too. I don't mind improper fractions in this class, okay? The rest of the world maybe get pissy at you, but here in math class, improper fractions are totally okay because I will be improper throughout the entire class, so you might as well get used to it. Alright? Okay. So, again, it's just be careful making sure that whichever of these you give me the right version of it, right? Don't tell me it's negative 3 and then 0.4 for some reason, right? That would make me sad. Alright? Alright, so, ready for some twists? So 12 minus 2x equals 4. Alright, so what do I have to do first here, folks?
Subtract 12. Finish that.
Alright, good. So note, the 12 is what we were working with, right? Subtract 12. When I subtract 12, what am I left with?
Negative 2x equals negative 8.
Negative 2x. Note, folks, don't lose this minus sign when you do the subtraction. That's one of the bane of algebra students. Happens all the time, the disappearing minus signs, okay? If you make a mistake, this is the sort of mistake where it happens. Where all of a sudden, for whatever reason, You just get in a hurry, and that minus 2x just becomes 2x because you forgot to bring the minus sign down. Okay? That will be where most of you make a mistake if you actually make one. All right? Now, there's this minus sign in front of there.
It's on the other side too, so x equals 4.
Just
Three, add a 2.
divide by negative 2. X
Divide by
equals
negative
4.
2. Exactly. Note, folks, that this 2, it is minus 2, but it is really negative 2 times x. And it's perfectly okay to divide by the negative. What happens when you do a negative divided by a negative? It's positive. All right, very good. So when you take negative 8 and divide by negative 2, x is actually a positive 4. All right? And this is one of those where you should be a little bit nervous about it just because dealing with double negatives is always a pain. And so it's never a bad idea to make a quick check, right? Does it actually work? Is 12 minus 2 times 4 equals to 4? And this is where you guys say, oh yeah, I remember my order of operations. I know I need to do 2 times 4 first. And yeah, I see that it works, because what's 12 minus 8? 4. And therefore those two are the same, and I'm happy. Okay? So again, this is just me making sure that you're careful. Don't lose minus signs, and be careful when dealing with subtraction of integers. Alright? Alright, not too bad. Alright, so let's see. Do we need to do any more of those? No, I think we're good. So, one of the other things that I will expect you to be able to do, though, is use the distributive property. The distributive property, here's the way a mathematician writes it. If you take a number, a variable, a, and multiply by the sum or difference of a set of numbers, in parentheses, the a distributes to every term inside the parentheses. In other words, it multiplies everything inside. Okay? And again, this is a sad story, but it always makes me smile. That the last, probably like 3 years ago now, I had a student who, when I said, oh, we're going to learn the distributive property, and the student looked at me and said, oh, you mean rainbowing? And I was like, rainbowing? No, distributive property. And when I did the distributive property and drew the little arrows, what did it look like?
Rainbow.
It looked like a little bit of a rainbow. And she's like, well, it's a rainbow. And I was like, well, yeah, I guess. And I thought about it for a little while after I got over the sort of, you're weirder than I am thing. And I said, oh, no, that's not such a bad thing, right? Because rainbowing things makes it sound like it's good, right? But if you're asked to distribute something, that sounds like you're having a problem with your car, right? Because anytime you have a problem with the car, they'll always say, well, it's probably the distributor, right? It's like, oh, okay. And that's bad, right? So if you want to call it rainbowing, by God, call it rainbowing. I like it, right? As long as you're consistent and safe, we're all good, okay? So, and I do always tend to draw the little arrows, and I almost always try to use a separate color, so it probably will look like a rainbow. So, again, I will look at you weird, but it's okay. Alright. I assume you guys all look at me like I'm weird, so we're good. Alright, so once we start putting in, what does 2 times the quantity x plus 3 equal after you distribute? 2x plus 6. Yes. The 2 multiplies the x, the 2 multiplies the 3, and becomes 2x plus 6. Again, please be careful. For whatever reason, I had one student who always thought, no matter what this number was, it always came in front of the variable when you distributed. Because more times than not, when you do the distributive property, that's what you do. You just leave x by itself, right? So when you multiply by it, it always becomes the number right in front of it. And their brain said, oh, just put the number in front of x always. And that's what they did. And I was like, it's just one of those where you gotta point it out to people just to be safe, right? So what is 3 times 2x's? 6x, right? So please don't think that this number is always going to become the coefficient of x. You're going to multiply, and don't forget to do 3 times 4.
Minus 12.
And don't forget the minus sign comes along. Okay? Alright, now. One of the things that I also like to show students. What is 15 minus
There's
8
a-
minus 3?
There's a 1 in front of the parentheses.
In theory, yeah.
So you take those
But-
negative, that negative 1 times that first.
Note there are no variables inside of here, right? So, in theory, this is just do the order of operations. What should you do first?
8 minus 3.
8 minus 3. So what's 8 minus 3?
5.
5. And what's 15 minus 5? 10, right? Same thing. Why not? Do the math. What's 15 minus 8?
7.
7. What's 7 minus 3?
4.
4. When is 4 the same as 10? When your 10-year-old's having a really bad day. Which probably isn't all that far from true, right? So, note, why are these two things not the same?
These ones not in parentheses.
For the negative sign, the negative equals positive.
Yep. Negative signs distribute. Okay? There's no number multiplying these parentheses, and so you may think, well, it may as well be like those parentheses are not there, right? Well, if you just eliminate the parentheses, note, folks, you don't get the same thing. And that's bad. And the reason why is that the minus sign needs to distribute, right? What is a minus a minus? A positive, right? Remember, math is the only class where when you hit somebody, they get to hit you back, and it's a positive thing, right? Because 2 negatives make a positive, right? This is math class. Fighting is encouraged, all right? Not really, of course, but. And then again, 15 minus 8, 7. 7 plus 3. And hopefully your 10-year-old can actually act like a 10-year-old most of the time. Okay? So please note that minus signs distribute. Alright? And again, that's one of those common mistakes that students tend to make, is that they kind of say, if there's a minus sign and the parentheses are here, who cares? Just throw the parentheses away, you don't need it. Distribute the minus. Okay? So, with that bit of knowledge, what if I asked you to do, say, 2 times x plus 3 minus x plus 4? And I said, simplify this equation. Or, sorry, expression. So when you're simplifying expressions that have parentheses, folks, distribute. So what does the first parenthesis turn into?
2x plus 6.
And what does the second parenthesis turn into?
Minus x minus 4.
Yeah, minus both of those, right? Because the minus distributes to the x, and the minus distributes to the plus 4, and makes it a minus 4. All right? And so you just have to be careful with those. Now, combine terms that can be combined in here. If you had 2 x's and then you killed one of them,
X
you've only got one left.
plus 2.
If you would like to write the 1 in front of the x, I am okay with that, folks. It's not wrong to do it, right? It's just a little weird, all right? And then 6 minus 4 is 2. Make sure it's a plus 2. So that expression simplifies to just x plus 2. All right? Not bad? Okay. So now let me throw some fun with it here. So let's try this one. Let's solve an equation with that. So let's suppose I gave you 3 times x minus 1 minus 2 times x minus 4 equals 5. All right, here's where it starts to get fun. All right, let's do our first distribution. What do we get when we distribute the first parenthesis?
3x minus 3.
Okay, so the 3 just distributes. It's all well and good. All right, now, there's a 2 and there's a minus. Folks, both of those go for the ride.
Negative 2x plus 8.
Yeah, so the minus 2 gets to the x, and you have regular old minus 2x. But then be careful, right? When the minus 2 multiplies a minus 4, 2 negatives are a positive. And now, combine everything, folks.
X plus 5 equals 5.
Alright, so you have 3 x's and you took out 2 of them. There's only one left. A minus 3 and a plus 8. Again, be careful with those. Now what do I do to get x by itself? Subtract 5. Uh-oh.
X equals 0.
Does that make sense, folks? Can you have an answer x equals 0?
Yeah.
Of course you can. 0 is an awesome number, folks. In fact, it's usually my favorite number. So don't be surprised when you get an answer that's 0, because I like 0. Okay? Are you sure it's the right answer, though? What are you going to do? Yeah, check it. Plug it back in. See if it actually works. I was using some blue in that problem, so let me use green to check it, right? So I have to do 3 times 0 minus 1 minus 2 times 0 minus 4 somehow has to be 5. Whoa.
It works.
What do I have to do first up there, folks?
You
They're just numbers, though. So do your normal order of operations. What comes first? Parentheses. What's 0 minus 1, folks? What's 0 minus 4? What's 3 times negative 1?
Negative 30.
And now here's where it's a little bit weird, right? This is technically what's 2 times negative 4, folks.
It's going to be positive 8.
Yeah. I will write it as minus a negative. What happens when you subtract a negative?
Positive.
Add the positive, right? So this is another one of those things you have to get used to in math. The subtraction of a negative is the same as adding the positive, right? So if you take away an IOU, it's like you made that much money, right? If you owe somebody $5 and someone else comes along and basically pays off your $5 debt, what happened to you? You basically made $5 because they subtracted an IOU. Same concept. 5 is 5, which makes us feel all warm and fuzzy about the fact that x can be 0. Okay? Not too bad? Alright, so one last minor trick that might happen to you when it comes to straight out algebra, no word problems. What did I do to you here?
You have X on both sides.
X on both sides.
Get it on one side.
We need to get all of the x's on one side and all of the numbers on the other. How do we get an x from one side to the other?
Tricks.
Subtract or addition, depending on whichever one you have to do. So you can go either way, folks. You could subtract 2x and then subtract 2x over here, or you could subtract x and then subtract 1x over here. Which do you prefer to do?
The X.
Why the x?
Otherwise you're gonna have
There's nothing.
It's easier, yeah. You're going to wind up with positive x values. Advice, when you have x's on both sides of the equation, do what it takes to get positive x's. Negative signs, folks, suck. Okay? Generally. Alright? So in this case, the way you get an x from one side to the other is the same way you get numbers from one side to the other. Add and or subtract. Okay? So if I subtract an x from this side and subtract an x from this side, and then last but not least, what do I do to get rid of that 5?
You forgot to carry the negative sign down on the 2.
Shh, I need to make a mistake. So how do I get rid of that 5? This is the mistake that I often see on students' homework problems, folks, is this, right? And then they stop and say, great, I got the answer, move to the next problem. You guys have already pointed out it's wrong. Why is it wrong? Why isn't this the right answer? Yes, because I didn't put the -2, but so what? Who cares if the -2 is 2?
It doesn't work.
It doesn't work, right? The whole point is when you plug this back in, it won't make the equation true. When you plug the numbers in, right? When you say 2 times -3 plus 5 equals -3 minus 2, are those two numbers on each side the same? Well, this is going to turn into -6 plus 5. This is -1. This is -5. It's not the same number. That's when you know you made a mistake. Okay? And the whole idea of checking is that now you need to go look for it. Okay? And in theory, if you guys would have let me just make the mistake, I would have said, here's where it is. I didn't carry the negative sign down along with me. I needed this to be -2. There's my mistake. And my advice, folks, when you make mistakes like that, and if it happens, don't worry about it. What most students do is erase everything. Please don't. It's really nice for me to see you guys find mistakes and fix them, and actually see it, right? So the way I would ask you to fix this mistake is say, oops, just put a big X through it, and then do the problem the correct way right below it, so that you can show me that you noticed where your mistake was and that you went in and fixed it, instead of just erasing everything and me not getting the joy of seeing you fix a mistake. Okay?
You can't just pick
So
up
that
where
means
we
you're putting
made the
like
mistake.
big old gaps between each problem. So you said 3 pages, right? So that's like
You are going to leave more space from now on, because that's not enough space.
You can always work on these problems on separate pieces of paper. That's perfectly okay. I have no problem with that. Again, all I'm saying is that it is nice for me to see if you guys actually do check the problems. And if you really do notice that you made a mistake, I never get to see it, right? Because everybody's like, oops, I made a mistake, and then they erase. And I can see the eraser marks, but I'm never sure if it's the eraser marks because you did 2 plus 5 and said it was 1, or you did a check and saw that you made a mistake and went back and fixed the whole thing, right? I mean, it would help me to see when you guys fix your own mistakes, okay? That's all I'm saying. And so I would ask you, if you see this, to just, instead of erasing, I know it's really hard not to, but just sort of scratch it out and say, oops, and do it off to the side.
Can we just start over where we started the mistake?
Sure. Oh yeah, absolutely, absolutely. Yeah. I mean, these problems aren't going to be long enough that it will make much of a difference, is my guess. But that's the idea behind it, though. Okay. So, this is mostly me showing you that yes, this can happen. Please redo. And if you have to erase it because having a mistake in your problem makes your entire skin crawl, I understand. right? And so go ahead if you have to, but I would just ask you not to, so that I can look at it and go, oh, cool. And then, you know, that's the sort of thing that I would like give extra credit for randomly at times. Right?
Oh, cool.
Making a mistake.
No,
Making
for
a mistake.
fixing
Showing
a
a
made
mistake.
mistake.
Then we can do that on every single problem.
I know.
And
It would be a little egregious after you did it once or twice. But, I mean, if it happens once and you notice it and you're like, hey, look, oops, I'm an idiot. And I'd be like, oh, yeah, me too. And, you know, I'd +1. Right? That's the sort of...
that's odd to me that we would get extra credit for that.
For fixing a mistake,
Well, don't make him change his mind.
of course, the joy of life is noticing mistakes and not redoing them, right?
But life doesn't hand you extra credit for that.
Maybe it should. All I'm saying is that I potentially will. I'm not saying I will automatically, but it's the sort of thing that, you know, when I see it, it's like, hey, it warms my heart. And my heart doesn't get warmed very much, guys. Remember, I teach math, right? There's a hole in the wall in my house where I grade papers, and when I'm done, I just... My wife has gotten to the point of taping a little pillow up on the wall when I'm grading, so because you do things. I mean, it happens, right? When tests come around, you get nervous, you get excited, you get anxious, and you'll do something like 5 minus 2 is 7, and it's because you added subtract. That sort of stuff makes me bang my head against the wall. So I'm like, oh, you know better, bang, bang. So, but anyways, I don't get a whole lot of warm fuzzies. So if you can give them to me, I'll take them. All right.
It took you more than one time of doing that before she put a pillow up?
She laughed more times.
She's mean.
All right. So that problem, folks. This problem is about as you know. This is the hardest problem you will get in this class. Okay, right here. Let's do 3 times 2x minus 1 minus 2 times let's go 5 minus 2x equals 9. Whatever. This is about as hard as it's going to get, okay? This is as deep as the algebra rabbit hole we will go into on. Alright, so... Alright, so, what am I going to do first?
Distribute.
Distribute. What does my first parenthesis become?
6x minus 3.
6x minus 3. Alright. Now, be careful distributing the next.
Minus 10 plus 4x.
Yeah, So negative 2 times 5 gives you a minus 10
Plus 4x.
plus 4x. What do we do next?
Combine 6x and 4x for 10.
6 x's and 4 x's gives us 10 x's. We've got problems.
Negative 3, negative 10, make negative 13.
Negative 3 and negative 10. Don't lose the minus in front of the 3. Too many times I'll see 3 minus 10 becoming negative 7 there.
Add the 13.
Add the 13. Equals 22. Last but not least, divide by 10. What's 22 divided by 10?
2.2.
X is 2.2. That's about as scary as it's going to get, okay? We're not going to go into really deep algebra, all right? Not bad? All right. So, the whole point of this, though, of course, is to get to this. Okay? I just want to get us started on it. We've got like 5 or 10 minutes here, so give me a little bit. We won't do anything relative too deep. We'll just do some basic stuff. All right. All right. One more than a number. is 4. What is my number?
X equals 3. X plus 1 equals 4.
Alright, so x plus 1 equals 4. How do you get x plus 1 equals 4 from that first sentence, folks?
A number equals X.
A number is x, good.
1 more than is plus 1.
1 more than is plus 1.
Is 4 equals 4.
Okay, awesome. One of the handiest tools to working with word problems, folks, is realizing that the verb in the sentence is actually the equal sign 99.9% of the time. And the cool part about English is that, generally speaking, everything that becomes before the verb is on the left-hand side of the equal sign. Everything that comes after the verb is on the right-hand side of the equal sign. Okay? That is almost always how the math works, and it always breaks down with the English. Alright? So one of the things that you're going to want to do when you are reading word problems is write straightforward, simple equations that represent whatever it is that sentence is. Alright? In this case, 1 more than a number, right? So x plus 1 is 4, and so then what do we do to get x by itself? Subtract 1, and x is 3. And the reason why this is a relatively tricky problem, folks, is that what a lot of students do is they see 1 more than. They know that means plus. They see the number 4. What's 1 plus 4? And it's really hard not to have that stick in your brain, right? The only way that you can see that you really need to subtract in a problem that says 1 more than is because you wrote the algebra out and you know how to manipulate it, okay? People who are not decent at algebra will often say the answer to this question is just 5. So when you can see this and feel in your brain that 3 is the right answer, that's you knowing at least a little bit about algebra, all right? Or at least reading carefully enough not to make standard algebraic mistakes, okay? So please be careful reading these things, and when you get to the word problems in Chapter 5, this is the way you make it easier, is by reading the sentences and saying, how do I break this sentence down, all right? All right, now, here comes another classic thing that happens in the homework way too often. I have 25 apples and 10 oranges. I ate 1/5 of my oranges. How many oranges are left? Note, folks, I have 25 apples.
Who cares? That's useless crap.
Exactly. Please note that there are going to be more times than you can imagine where there will be numbers you are given that you do not need to use. Don't use them if you don't have any directions on what to do with them. Alright? So, in this case, you have that first sentence. Do you need to write an equation for the first sentence?
No.
No, not really. Okay. Now the second one, though, I ate 1/5 of my oranges.
10 minus 1/5 equals X.
So here's what our thought is. 10 minus 1/5 equals X. What's 10 minus 1/5, folks?
Yeah, I would just
Okay, so good. We're on the right track with subtraction. Why is subtraction the right thing to do, folks?
Because you have to subtract that.
Yeah, because when you eat them, you subtract them, right? But the key here is realizing that 1/5 is not an orange. It's 1/5
of 10.
of my oranges. Whenever you see a fraction followed by the word of, multiply.
I
don't know the answer.
did 10
I don't know that's
We do 10 multiplied by 4/5? Would that work?
That works too. If you're seeing past the problem, right? And we'll get to that. That's after we do it this way. Then we'll move to that way. All right. So that's the key. Is that you eat 1/5 of the oranges. 1/5 times the 10 oranges that you have. Now, here's another truism of math, folks. Multiplying by 1/5, the same as dividing by 5. This is one of those things that people tend to think they don't believe is true, but it always is. Okay? When you multiply by 1/5, folks, this is 1/5 times 10 over 1. How do we multiply fractions? Straight across, right? 10 over 5. And now what are we doing with the 10? Dividing by 5, which is the same as multiplying by 1/5. All right? So when I have students who do this problem, they tell me that in their head, I did not multiply by 1/5. I divided by 5. And I agree with you. But what you really did was took a huge mathematical leap and said, I know that multiplying by 1/5 is the same as dividing by 5.
I have a question. I mean, just personally for me, it's easier for me to be able to, to be able to take off like 20%.
We'll get there. That's chapter 6. We're dealing with, realize that I'm going to ask you to take off 1/9 of it. What's 1/9 as a percentage? Do you know it off the top of your head?
0.3.
No, that's 1/3. 1/9 is 0.11111. But again, it's also 1 repeating. Can you do 11%? No, because you're missing all the repeating ones. So I agree with you that when it's 1/5, you can just think 20% because that's a great translation. But realize that some fractions don't translate to percentages nicely. And I like those fractions that don't. I like sevenths and ninths and 11ths and 17ths. Annoying fractions. So you need to be able to work with them is basically what I'm telling you, okay? And so yes, in this case, we ate 2 oranges, if I could spell the word orange correctly. And if you've eaten 2 of them, how many are left?
8.
Sorry.
I was gonna ask, can we just get a word problems like that? Can we just get an answer? Do we have to?
Oh, no. If you know how to get to the answer like really fast without doing much thought, you can just write down, hey, I know it's 8. I'm happy with just writing down 8. Okay? As long as you can do the same problem if I say that there are, 356 of these and I ate 2/7 of them, right? As long as you can do it that way without you having to write anything down, we're all good. This is just a problem where, yeah, you probably can do it in your head, right? So 10 minus 2 equals 8 oranges left. And then the other way of thinking about this problem, right? If you ate 1/5 of the oranges, folks, what fraction of them are there left? 4/5, right? So the other way of attacking this problem is saying, hey, 4/5 of the oranges are left. Which, in some instances, is the answer students think is the correct answer, but I asked how many oranges are there, not what fraction of them are there. So it's kind of like, giving the answer but not quite giving the whole answer. So what is 4/5 of the oranges? And again, you have 4/5 of, what do you do with an of followed by a fraction? Multiply 10 over 1. How do we multiply fractions? Straight across. And what's 40 divided by 5? 8 oranges left. And both of those ways, any of those ways that you did that problem, and again, even if you can do it in your head and write 8 oranges, that's still okay. All right, I'm not forcing you to show like all of your work necessarily. I just want you also to realize that sometimes the numbers won't be so nice. Okay, and I guarantee you on the test that the numbers will not be as nice. Okay, so they're going to be numbers like 4,217, and you need to know how to divide that by 7.
So the majority of lost points that I did on the first homework, I know how to do the fractions. I was just making dumb mathematical errors because I wasn't using my calculator for the first time in like 5 years. So is that going to be? That's going to be like the test though. So
Yes.
we are going to have to. Okay.
Yeah, on tests, folks. If you just want to write the answer down, I am perfectly happy to grade you. But if you just write the answer down, you're either right or wrong. If you show me work and you do all the correct work, but at the very end you do
Make a
4/5
mistake.
plus
Okay.
3/5 is 9/5.
Okay.
So you add 4 and 3 and get 9. Then I'll only take off 1 out of 5 instead of all 5 out of 5.
Okay. So yeah. So we go for partial because I was making like dumb mistakes like I would minus something and I would say it was 5 when it was supposed to be 4. And
Right, exactly. I mean, those sorts of things on homework, yeah, I'm sorry, I kind of have to ding you. But on tests, you would only miss 1 out of 5, 6, 7, 8 points.
So in your test, is it going to be like laid out so we can do our work on there, or do you hand out separate paper and say what?
I would recommend bringing your own scratch paper based on potentially how big you write numbers. I try to give enough room so that you can show, but it's not, on this first test, it's not done that well because I want to make it fit on one page and there's probably not enough room. So on the first test, I strongly encourage bringing scratch paper, and I will allow you to have it, so don't worry about it. And so when you get to those problems, if you do them and you need to write everything out, that's cool. Again, it's kind of up to you as to whether or not you think you can make it fit on the test or not. And if you don't, then grab some scratch paper and go. It's fine. Alright? Alright, so folks, this got us through most of Chapter 5. Basically, the plan on Wednesday then is to come in and do probably 45 minutes to an hour of word problems and getting to all the types of word problems that you got on the homework. Note that some of them are mildly tricky, so bear with me. We will start with some simpler ones and then work our way into the really hard ones. And hopefully we will have a good half an hour at the end of class on Wednesday where I can hand out the review sheet and we can go through as many of those as we can go through before we're going to call class. Okay? Alright, so if you did not turn in the Chapter 3 homework, please get it to me as soon as you can. It's okay. I'm not going to mark you late or anything like that at this stage. If you would like to pick up your Chapter 2 homework, I do have it here. Monroe folks, I will mail yours over so that you will get it on Wednesday.
And then, did you still want us to sign in?
Today, don't worry about it. At this stage, you're here or you're not here. They're alphabetical by last name, so,
Oh, that helps.
because I am who I am, so you should, yeah.
Would you like print mine off? I like
Probably.
it online.
Oh, okay. Yes. That's
If you did it online, it's just online. I didn't actually print it off.
Oh, okay.
I
But
think
there
it was-
should be comments on the actual homework on Blackboard.
Oh, really?
So yeah, so if you,
comments, but is it like on the problem or like
it's on the, yeah, you have to open it up and see the comments that are associated with the problem.
I just assumed it was like really dumb errors on my part. like, you know.
Did you not-
so,
Did you not grade my chapter?
Chapter 3, I have not graded any Chapter 3 yet now.
Yeah, I couldn't believe my kids had off. And then the first day, I made it
Hello.
down. So I was like,
So I could email you
Mhm.
and see chapter 5.
Perfect.
And then just turn in chapter 3 when
Yeah, when you get done. Wednesday would be best,
I... Okay.
but,
yeah.
you know, sooner better than later, but
There's that, and then I didn't have you sign from the previous week.
I would vouch for it if you needed me to.
And then you know to take my test to Testing Center for Accommodation.
Oh, okay, yeah.
Yep, okay.
Just remind me on Monday
Okay.
before class
And I'm
because,
going to email her too.
yeah, you have to be in touch with her. She will send me an email too, but I'll still forget on Monday. So
Okay.
on Monday, as soon as you get here, come to class and say, Marshall, send my test. And I'll be like, oh, yeah, because I will
Okay.
forget. Just
Sounds good.
realize.
So in here we won't be like solving for like linear equations and
Doing
trinomials
lines and yeah, no.
Oh, okay.
No.
Is there a way to test out of this class?
Yeah, but you have to know how compound interest works, and you have to know how to read financial tables. And if you don't know how, then you usually don't do it on the test out, and you just spend money to not pass it. You can give it a whack if you know how to use the tables to do financial
I did one class
lookups.
with it, but it was like so long ago.
Yeah.
Like, but I want to get.
So your
I know.
your check marks are the wrong ones, right?
No, check marks are good. X marks are bad.
Thank God. Check
That's
marks are
what-
good.
Yes, check marks are
Oh,
good.
my God.
That's just me noting to myself. I graded this one.
It doesn't snow on Monday.
Ooh.
Yeah, no snow on Monday. That would be
Okay.
bad. Please snow.
Yeah, we don't need to be anywhere.
Yeah, well, I like can't get out my
Ugh.
God, that all those red marks threw me.
Yeah, sorry about that.
Like, oh.
All right, Steve, what do we need to do?
I don't know. I'll be gone from Sunday, Monday, and Tuesday. The state.
Okay. So how do you want to do it? I mean, I am more than willing to let you come in Wednesday, as long as you get the test taken before class on Wednesday. So anytime Wednesday morning is fine with me.
Okay.
Anytime this week is okay too. If you wanted to take it before you go, I would totally understand.
Yeah, I mean, I got obligations. So if I knew ahead of time, I would be able to be, it'd be Friday or something. But
That's perfectly okay. I have no problem. I'll just send it to the testing center, and you can go anytime.
unfortunately, I got to help my pops, and I'm going to be on the road. So,
I know.
well, I mean, for him.
Okay.
I got to drive for him. So.
Yeah, no, and that's
Just
why
help him out
I'm.
a little bit, because he's having some problems. He can't get anybody with CDL, so I got to help him out.
And that's cool. You just have to tell me
Like Wednesday.
either Wednesday before class, because on Wednesday I plan to go over the test in class. So even during class, I would say if you wanted to, I would like send you to the testing center during class, and just instead of coming to class and going over the test, you just do it.
Oh,
I mean,
okay.
that's okay. I wouldn't recommend.
Because I got a class before this class. That's why I was
see.
kind of like trying to.
Yeah,
do all
see,
these-
can you do that? Yeah.
Yeah, I was trying to do all these. Okay, and like this and that, and but that would be great if we could do that.
No, that works for me.
Like during class on Wednesday.